Good morning, everyone. For this quarter, we only have one learning competency to achieve, and that is to set network configuration. Our lesson for today plays a big role in the configuration settings of a network. Let us now start our lesson with this activity. Can you answer this question? Without it, your computer, your mobile phone, and any other devices cannot connect to the internet. Can you guess the word? To help you find out the answer, please visit this link tinyurl.com/ictgeeks and play the jigsaw puzzle. You may pause this video for a while, get back to me once you're done with the game. Okay, so what is it that your computer or gadget need to have to connect to the internet? When you visited the link I provided a while ago, your basic math skills should have helped you reveal each piece of a puzzle. After revealing the pieces, you should have formed this image. So the answer to the question is IP address. An IP address is set to a device in order to connect to the internet. IP stands for Internet Protocol. Internet Protocol is a set of rules that makes internet work. So how does an IP address work? Let us use a simile to make an idea more vivid. A simile is a figure of speech involving the comparison of one thing with another thing of a different kind, used to make a description more emphatic or vivid. This is an example of a simile. Playing chess with Kinsley is like trying to outsmart a computer. To explain, playing chess with Kinsley is being compared to trying to outsmart a computer. The point is that Kinsley can think in a powerful manner that resembles the way the computer operates. Kinsley is not like a computer in any other way. Again, let us use simile to better understand how an IP address works. An IP address is like a house address. Every house needs to have its own unique address. If you need to send a letter via postal service, you need to write a destination address on the envelope. That way, when you send the letter, the postman knows exactly where to deliver it. Now, the address must be unique. Otherwise, your mail could be delivered to somebody else. Computers work in the same way. Each computer in a network needs to have a unique address called an IP address. If a computer has an IP address, it can receive and send data to other computers in the same network. Now, can you think of other good simile to describe and understand IP address? Go ahead and think about it. Yes, you might have thought of an IP address like a phone number that your computer uses to talk to devices attached to the network. An IP address is like your LRN, or Learner's Reference Number, which is a unique identification number assigned by DepEd to the student. Just like your LRN, an IP address is unique for each device. So no two devices in a network can have the same IP address. There are two versions of an IP address. We have IP version 4 address, and IP version 6 address. IPv4 address is a 32-bit numeric address written as 4 numbers separated by dots. Example, 172.16.254.1. IPv6 addresses are 128 bits long. Here's an example. In this picture, we can also find another examples. 192.168.1.1 is an IPv4 address, and the other one is an IPv6 address. Of these two versions, IPv4 is the most commonly used, so we will focus our discussion in IP version 4. The IPv4 addressing system is divided into 5 classes of IP addresses. An IP address consists of 4 octets. In this example, the value of the first octet is 192. The second octet is 168. Third octet is 2, and the last octet is 33. Each octet can contain any number between 0 to 255. Now, how are we going to identify the class of an IP address? All the 5 classes are identified by the first octet of the IP address. Please take note of that. Let us refer to this table for the IP address classes. If the first octet has a value that falls between 0 to 127, then it is Class A. Class A supports 16 million hosts or devices on each of 127 networks. That's why Class A IP addresses are used for huge networks like those deployed by Internet Service Providers or ISPs. Class B IP address has an address range from 128 to 191. Class B supports 65,000 hosts on each of 16,000 networks. Class B IP addresses are used for medium and large-size networks in enterprises and organizations. Class C IP address has an address range from 192 to 223. Class C addresses are the most common and used in small business and home networks. These support up to 256 hosts on each of 2 million networks. Class D has an address range from 224 to 239, while Class E ranges from 240 to 254. Class D and E addresses are least used. Class D is reserved for special cases, largely for services and applications to stream audio and video to many subscribers at once. Class E addresses are reserved for research purposes. Take a look at the following IP addresses. Which classes are they in? Again, remember that the value of the first octet of the IP address decides the class of the IP address. The first octet of 172.16.1.20 is 172. Referring to the table, the first octet of Class B ranges from 128 to 191. Therefore, the given IP address belongs to Class B. In the second example, the first octet of 192.168.1.10 is 192. Based on the table, the first octet of Class C ranges from 192 to 223. Therefore, the given IP address belongs to Class C. Now, try to answer this on your own. Determine the class of each given IP address. I am giving you 5 minutes to do this activity. Please pause this video and play it again as soon as you're done with the activity. Let us now check your work. We will refer to the same table. In number 1, the first octet is 19, therefore it is class A. Number 2 has a first octet of 240, then it belongs to class E. Number 3 is class D. Number 4 is class C. And number 5, it has a first octet of 185, therefore it belongs to class B. So how was it? Did you get a perfect score? Congratulations! We will now examine the parts of an IP address. An IP address has a network address and a host address. The network address is the portion that specifies the unique number assigned to your network. The host address is the portion of the IP address that you assign to each host or device. It uniquely identifies this device on your network. This table shows the network portion and the host portion for each class of an IP address. For class A, the first octet is the network address, and the remaining octets refer to the host address. For class B, the first and second octet pertain to the network address, and the last 2 octets are for the host address. For class C, the first 3 octets are the network address, and the last octet is the host address. There are no defined network and host addresses for class D and E, since they are reserved for multicast and for research. Let us consider this IP address 172.16.0.1. With the tables as our guide, let us identify the network and host portion of this IP address. First, determine the class of the IP address. Since its first octet is 172, then it belongs to class B. Then look at the other table. The first and second octet of the class B IP address refer to the network address, and the third and fourth octet are used for host address. Therefore, we can break this IP address into 2 parts. The network address is 172.16 and the host address is 0.1. Let us have another example. 192.168.1.8 belongs to class C. The network address for class C consists of the first 3 octets. Then 192.168.1 is the network address, and 8 is the host address. Now, try doing this. I am giving you 5 minutes to complete this table. Please pause this video and play it again as soon as you're done with the activity. Welcome back. Let us see if you get it all right. In 9.4.3.47, 9 is the first octet, so it belongs to class A. In a class A IP address, The first octet, which is 9, is the network address. And the host address is for the 3.47. In number 2, 203 falls under class C. Its network address is 203.42.62. And 1 is its host address. Number 3 is a class B IP address. Its network address is 151.10 and its host address is 13.55. I hope you got a perfect score in this activity. Now, why did we learn about the class of an IP address and its corresponding network and host address? Here's the application. Examine the two pictures. Which can communicate directly to each other? Is it figure A or figure B? Analyze the IP address assigned to each computer so you will have an idea which computers are in the same network and which are in different networks. Of course, those IP addresses that belong to the same network will have a communication to each other, right? Now, I am giving you 5 minutes to think about it. Pause this video now and get back to me as soon as you find out the answer. Okay, have you thought about it? Let me help you. Let's take a look at figure A. Here we see two computers with an IP address of 192.168.1.101, and the other has an IP address of 192.168.1.102. Both IP addresses belong to which class? Yes, they are both class C. Then, the network address of these two IP addresses is 192.168.1. They have the same network address. Consider also the host address of each PC. Remember that the host address must be unique. No two computers or devices in the same network would have the same host address. Both PCs have different host address. The first one is 101 and the second is 102. Now, let us examine the second diagram. The first PC has an IP address of 192.168.1.101, and the other has 169.254.17.251. The first IP is class C, and its network address is 192.168.1, while the second IP is class B, which has a network address of 169.254. Do you think both computers belong to the same network? You are correct. They are in different networks since they have different network address. Going back to the question, which can communicate directly to each other? Is it figure A or figure B? Yes, figure A shows two computers belonging to the same IP network and therefore can communicate with each other. Figure B shows two computers belonging to different IP network which cannot communicate directly with each other. So in figure A, when PC1 sends a message to PC2, PC2 can receive the message and can reply to PC1. In figure B, when PC1 tries to send a message, PC2 would not receive it since there is no communication between the two. Let us have another example. Can these computers communicate with each other? Examine the IP address assigned to each computer in the network. The first three computers can communicate with each other since they belong to the same network. They all have the same network address of 128.15. Their host address is also unique. There is no duplicate in the host address. Again, since they have the same network address of 128.15, the first three computers can communicate with each other. How about the last PC? PC4 has a network address of 128.10, and it is different from the network address of the three computers, which is 128.15. Therefore, it cannot communicate with the rest of the computers. Again, PC4 does not belong to the same network. It has a different network address of 128.10. Therefore, it cannot communicate with the rest of the computers. I hope you understand. How about this one? Can these computers communicate with each other? Given the following IP addresses, all IP addresses are class C. Because the first octet is 195, it falls under class C. So they all have the same network address of 195.15.1. The host address are also unique. No duplicate. We have 4, 3, 45, and 91. They all have different host addresses. Therefore, all computers can communicate with each other. To assess whether you understand our today's lesson, here is your performance task. You will draw a network diagram with the following elements: 1 unit of 8-port network switch, 6 desktop computers, 1 network printer connected directly to the switch, and 1 CCTV camera also connected directly to the switch. Then, you will assign an IP address to each of the devices in the network. Use Class B IP addresses. Your work will be graded based on the following criteria, with its corresponding points. Your network diagram should include all the given elements. It should be accurately labeled. It should also include lines to show the connection of each device in the network. It should show the correct IP address assignment. And lastly, it should be neat and visually appealing. The highest possible score for this activity is 30 points. In accomplishing this task, you may choose from any of the options below. For online asynchronous class, you may draw the network diagram on a short bond paper. Take a photo of it and attach it to your assignment posted in the Google Classroom. You may use Cisco Packet Tracer mobile application or any other drawing application to draw your work, and take a screenshot of it and attach it to your assignment. For modular class, you may provide a hand-drawn copy of the network diagram, or you may also use any drawing application and submit a printout copy. Let me show you some of the model outputs made by your classmates. These outputs were submitted in the Google Classroom prior to posting of this video. Please take a look. For your reflection, I'd like you to answer the following questions. What have you learned from today's lesson? How will you apply your learning? These are some of the reflections submitted via Google Forms. Okay, that's it for today. For any question and concern, you may contact me at 09777065 or find me on Facebook at Jixie. That's it for today. See you again on our next video lesson. Bye guys!